So,
Started.
yeah. Hello everyone. Our project is Green Harvest and it focuses on improving rice hill production in Madagascar. Our team here, the project combines data analysis, machine learning to create predictive model that helps farmer and the government to make better decision in rice production. Second slide. So the rice is the main staple crop in Madagascar, but it yields much slower compared to other top producers like China, India, Vietnam. We aim to bridge this gap by using data-driven technology. Our model predicts rice sales using environment, agriculture data, helping improve productivity, lower the risk. The project ultimate goal is to make data-driven decisions accessible to stakeholders and the local farmers. Next slide. This slide shows our team members who contributed to the project, who played important roles for data sourcing, cleaning, analysis, model development, and dashboard design. We work together to ensure all parts of the process, technical and analytical, align with project objectives. Fourth slide. The project progress overview, we summarize the development stages, began data sourcing from Firostat and the government of Madagascar. We moved to data selection sources, initial development processing, followed by data modeling and development. Currently, we are working on dashboard prototype, which visualize prediction inside easy data decision making overall project. We have received the milestone. In this slide, business process diagram flow, we have shown starting from data collection, storage, cleaning, exploratory data analysis. We performed engineering and model training. The results are used to decision support and feedback loop continues improve the model. Next slide. The tools which were used mainly comes from Freostat government of covering the period 2019 to 23. The data set includes 31 variables, nearly 200,000 records related to crop type, area, yield. We also included comparative yields data from top 25 producing for benchmarking. All our analysis model development are done in Google Colab and the project code is available through Google Colab. The next come the data sources. We focused on keeping the numerical variables and model training efficient. For efficient and accuracy, we encoded categorical values and standardized data format to ensure compatibility with the algorithm. This helped us to simplify the data set, reducing noise before moving to modeling phase. Now I pass on the floor to Thomas. Thomas, you are on mute.
Tomas, you have the floor.
Thank you. So the next thing we did was look at data selection. So we had so many different variables, and some of them were categorical. And we what we needed to do was look at this categorical data and dimensions, and then change them into numerical formats. So things like region name, sowing method name, variety type name, cultivation condition, so on and so forth. And then the solution was to encode them. And then what we ended up with was strictly variables that were numeric. So the next thing after that, what we did was we looked at the univariate analysis. So each dimension we analyzed and saw different data distributions within that. So first thing we looked at was sowing method, and we found that the direct sowing method was the most used, followed by broadcast sowing, inline transplanting, direct non-sowing, and random transplanting, rounding it out. So the most used was direct sowing. Then we looked at the actual distribution by frequency for irrigation type. And then what we found there was there were two that were equally prominent. One was the motorized irrigation. The second was the gravity irrigation. And they were both at 43.9% each. And then what was left or what was remaining was the rainwater irrigation. So that's what other farmers were using. Then we looked at the distribution of area in hectares. So we found that the most amount of area was for farms that had large area sizes. And then smaller farms were fewer. So that's how the distribution of area kind of worked out in Madagascar. So after we did the univariate analysis, we started looking at the multivariate analysis, and specifically we looked at average yield over region, yield by region colored by cultivated area, and average organic fertilizer used by each region. So what we noticed was Bonglava was actually had the highest in every category. So average rice yield by region, it was the highest, followed by Itasi, Diana, Boweni, and Vatovi. And then when we looked at rice yield by region for cultivated area, of course, Bonglava had the largest area, so it had the largest cultivated area as well, along with the highest rice yield for any region, followed by Itasi, Diana, Boweni, and Vatovavi. So finally, as you would expect, for average organic fertilizer usage by region, Bonglava was again the highest. So it has the most area, it would need the most amount of fertilizer, and that showed in the chart as well. Again, followed by Tassi, Diana, Vatovi, and Boeni. Then we go on to missing values. What do we do with missing values? So for us, we analyzed all of the uh, dimensions that had missing values, and you can see that based on the actual matrix that was created and the distribution of those missing values within those columns. So this is very crucial because, these missing values can distort the analysis. They can lead to biased or inaccurate results. They cause just plain errors. So we had to deal with them. One of the things that we actually ended up doing was for categorical variables, we ended up replacing those missing values with the mode. For numerical values, we ended up replacing those missing values with the mean. So that's how we handled our missing values in our data set. Then we ended up, going to the next phase, the outliers. What do we do with these outliers? So we had, used the interquartile range or the IQR method to detect these outliers first. So in fields such as area, culture, quantity of seeds, and so forth, we identified those outliers there, and there were a whole pile of them and with various ranges. How did we deal with those outliers? Well, there's four different ways we can kind of deal with them. One is through capping, one is through binning, one is through replacement, and finally through removal. Our decision based on what we did with the IQR was we decided to use capping. So that's how we kind of dealt with these outliers. So if we had original values of 529, 540, 1000, 880, we'd make them 7.495 as the cap value, for example, for area, so on and so forth for the other ones as well. So after that, we created our heat map. So we were ready at this point to do our feature engineering, created the heat map. We identified those variables that were highly correlated. We eliminate them. We also eliminated various other parameters as well, just like destination, production, and humidity level. After we had all that feature engineering completed, we had to save that out. So we cleaned the data, we saved the data in a CSV file, and that preparation file was going to be used for the next set of modeling. Right now, I'm going to hand it over to Stefan to lead the rest of the way.
Okay, thank you for giving me the floor. Now I will talk about the developing model. So we just have to choose our models and our metrics, and then we just use the guidance for that, the overfitting, the interpretability versus the accuracy, the data imbalance, and then the computational limits. For our models, we want to predict a continuous variable, which is yield. We use a regression model, and then we choose five of them: the linear regression, the supervector machine, the random forest, the gradient boosting models, and then the neural network. And we also choose the model metric accordingly: the MSC, the MSC, the MAE, and then the R2. Those tables just make a summarize of an overview of the metrics and then overview of the models. Let's now move to our code. Okay, so basically, when we just when we are talking about correlation metrics, we just click on it and then it doesn't work. So now, because we didn't click on the fast, so now it's good for the matrix um, correlation. So let's move quickly to development phase. What we did is that after having chosen our model, we try to just value good practice, and then we just split up our code into several functions. The first one was the evaluation model, that we call it evaluate model. Basically, there we use the cross validation with the faults, basically 3, 5, to compute our models with the key metrics. And then we just append all the result into a CSV file called the model performance summaries. And then we just run the fast shape. After having running our model, the model just provide us a good one, the best one, according to the Air2, and we just run the fast sharp on this model to identify the most influent features contributing to the model prediction. And then we got all of them, and we run our main. So basically, this is our code here. We just run the neural network, our models, and we just put together the testing and the training. Our model is there into get our models, and we just move after that to the prediction on a new data set. Basically, we use data to predict that we load first, which is year data to predict CSV, and after that we just make our prediction on this data set, and we display all the performance, which is year. Yes, we can see that according to the Air2, the best model is the random forest, which have an accuracy of 1, following by the neural network and then the gradient boosting. We also have the model execution time. We can see that the neural network have a good score, but it takes too long time because of the training plane. And then the linear regression, that one we have the lowest uh, time of execution. We also
12
have
minutes,
here
43 seconds.
we also have the model performance sharing, and then we just try to check for data leakage. Okay, now let us move back to our PowerPoint, talking about the exploratory data visualization. We have created some dashboard prototype which is here, and also the map prototype which is there. Now let us move to the communication plan, and I give the floor to Nishan.
Thank you to give me a chance. Now we are on a communication slides. On these slides, we highlights our communication played a major role in the keeping the green harvest project on the track. We followed a structured communication plan with regulating touch points every week. Our team meeting with Professor Lickbrick to review the project charter, data cleaning progress, and modeling updates. We also had a formal client meeting on the 11th of November where we present our initial modeling and gathering feedbacks. On November 12th, our initial team held a synchronizing meetings to choose the final evaluation metric R2, RMSC, and RMA to prepare the dashboard templates. Finally, on the 13th of November, we contract our external data advisor from the FO through emails, and they confirm that data set would be used for modeling. So overall, these consistent meetings helps us to keep everyone aligned. This slide is challenging. This slide outlines the main challenging we encounter. First, rice yield depends on the non-linear factor like irrigation, fertilization, and soil. This made modeling complex, so we used ML models such as random forest neural network. Second, the time and budget needs to be adjusted based on the client and supervisor feedbacks. We recognized responsibility and defined our workflow through our SharePoint plans. Finally, there are a trade-off between model accuracy and interpretability. To address this, we use Sharp to explain future contribution and simplified the models. Now we are on a budget, hour, and actual tools. These slides compare our plans, various actual hours, cost, and where we can use the some phases took slightly more times than estimated. For example, data management and data design required extra hours due to complex data cleaning and visualization. Similarly, for project initiation and planning went beyond this estimated because of additional client. Now we are on the activity activity completed. This slide highlights all the major tasks already completed. We successfully finished data collection, data cleaning, and data modeling. We also developed the predictive modeling and documents, all transformed to ensure the productivity. Status summaries. Next slide, please. This slide provide a clear status snapshots of them. Project data cleaning and feature engineering are fully completed. Modeling is in progress as we finalized performance metrics and integrated feedback.
Time.
Communication is going.